Hello, welcome to everyone. Let's start the topic quadratic. Under the topic quadratic, we have seen the quadratic inequality. Yes, the problem is given here is somewhat complex quadratic equation, quadratic inequality. In previous class, we have just seen that the one inequality with less than or equal to symbol or greater than or equal to symbol, like the way we have studied. Now it is somewhat different, like it is has a two inequality. One is x squared plus 4x minus 21 less than or equal to 0, and x squared minus 9x plus 8 greater than 0. The word and refers whatever the solution for both the inequality should be the answer. Okay. Okay, let's start the questions to solve. First of all, what the step is? First, we have to solve the equation for both of the inequalities. Okay. First, we can take the first equation. It's like 21. That is x squared plus 4x minus 21 equal to 0. We have to find 2 points whose sum multiplication is -1 and whose sum is 4. So we can choose the 2 points as two numbers as -3 and +7. Okay, let's split the terms and we can get the solution as -7 and 3. So we can use the table with the test values. In test values, I have chosen -9 for first interval, like minus infinity to 7. And then I have chosen a 0 as the test value in the interval -7, 3. And I have chosen 4 as the test value for the interval 3, infinity. And we have to test the values by substituting those test value in the inequality, and the LHS should be positive for first one, negative for second one, and positive for the third. So the solution set must be in 7 to 3. And also the equal symbols are present in the inequality, so we have include the endpoints in the solution set. Okay, so the solution set for the first inequality is closed interval -7, 3. Then go with the second inequality. X squared minus 9x plus 8 equal to 0. We have to choose two numbers whose product is 8 and sum is -9. That numbers are -8 and -1. Then the solution is 1 and 8. So there are three intervals. One is -infinity to 1 and 1 to 8 and 8 to infinity. Then you use the test value and find the values of the function. The possible thing is -infinity to 1 and 8 to infinity. This is a solution set. Then for the answer, it's a common values of the solution set in both the inequalities. That is a -7 closed interval, comma, open interval 1. Okay. Then we can prove the second inequality. It's somewhat tedious. That is it's a form of rational function. So we have to work on it more cautiously. First, we have to put equal sign there, and we have to check for which of the values the function should not be defined. The function for any rational function, the function is not defined for the for the x values whose denominator is 0. That is, x minus 5 should not be 0 and x plus 4 should not be 0. So the function in right side is not defined for x equal to 5, and function in left side should not be defined in -4. So the interval should be split up into two, like left of 5 and right of 5 and left of -4. Okay, then we can see the solution. We can just cross multiply these terms and we can take inside x squared minus 8x. Let us distribute the values using the distributive property, and then x squared cancel each other. 8x plus 6x is 14x and 15 minus 8 is 7 and the x value is 1 by 2. So the interval is split up as -infinity to -4, -4 to 1 by 2, 1 by 2 to 5, 5 to infinity, like 4 intervals. Okay. Then we can take the test values on each interval and find whether it is greater than or less than. there are two intervals which is greater than and also equal symbol is accepted on that. So we have to include the value 1 by 2, but we should not include the value negative 4 because the function is not defined at the point of negative 4. So the solution set for this inequality is negative infinity comma minus 4 union closed interval 1 by 2 comma 5. Yes. Okay. Thank you. Bye bye. See you then.